Hey guys, I hope all of you are having a wonderful day. So, I have a very interesting thing to share with all of you. As you know, our initiative as a part of Unacademy is to make learning fun for all of you. So, as a part of this initiative, we have the most competitive gamified UPSC Civil Services battle that is going to be held. The first one is going to be on December 6th, 2020, and the time is 11 a.m. I'm going to take a couple of minutes and share more details about this UPSC Unacademy Combat, right? This is an opportunity for you to compete with thousands of learners in India's biggest fortnightly competition. So, this is a competition that's going to be held on a fortnightly basis. That's on every 2 weeks, right? On Sunday, this particular competition will be held. So let me share a few details about this particular competition. So there are going to be challenging questions. It is going to be curated by some of the best Unacademy educators in the category. It is going to be super fast. It's going to be fun with real-time rankings. You'll be able to see you jumping up and jumping down. This gives you a unique opportunity to compete with the best of the best in this particular arena. The competition will be followed with detailed video analysis, right? There will be a video where solution analysis will be done by some of the top educators of Unacademy, right? So you compete, you crack, and you conquer. So you get a score which tells you about where you can improve, etc. So you can improve upon your speed and accuracy depending on your scores. With negative markings, you will know where you are lacking and what should be done ahead. There will be a leaderboard. You will get to know your rank, so you will get to know who are the best amongst all of you, and you can also aspire to be one of the leaders in this particular leaderboard. It gives you a rating, and the most exciting part about Unacademy Combat is that there are going to be so many awards, right? What are the awards are we talking about? So if you end up with the first rank, if you're the first person in the leaderboard, you get to win an Apple MacBook Air, and at second place you're going to get an Apple iPad mini, and at third place you're going to get Apple AirPods, and also the top 100 rankers will also be given a 1,000 rupee Amazon voucher. Alright, so that's what you can compete with the best, and also it's giving you an opportunity to win these amazing prizes, right? Bonus plus bonus. So anyway, so what is the contest format? So we are going to have this session. It's going to be lasting for around 45 minutes. There are around 60 questions, and there are going to be a total of 13 of such combats, right? There will be 6 sessions. The scoring will be relative scoring, and as I told you, this is a fortnightly contest, which means on alternative Sundays. That means every 2 weeks on a Sunday, you will be having this competition at 11 a.m. sharp. All right. So I hope all of you, participate in this particular course. So this is something that is a free initiative, so you will be able to access that. So for accessing this particular combat, you would be asked to give a small referral code. You can use my code. This is completely free. I hope all of you participate in this Unacademy Combat, right? Sign in using the Unacademy Learning app. Use my code AKMSIVA, and you will be able to have access to this. I wish you the best of luck in this and the upcoming Unacademy Combat. Thank you. So as you know, in the evening at 7 p.m. every day, I'm bringing to you this science and technology series on NCERTs. In the previous 2 lessons, we have been talking about the part 4. I've been discussing class 8 NCERT science textbook with you guys. So we're going to continue the trend, and today we are going to take up part 4, which basically means we are going to talk about class 9 science NCERT textbook. The course is being brought to you by me, Siva Prasad, as a part of an initiative by Unacademy. I usually teach live on Unacademy Plus. Usually I teach public administration, the optional subject for UPSC Civil Services mains examination, and science and technology for both prelims and mains examination. Alright, so starting with the very first chapter of class 9 NCERT, the first topic I would like to introduce to you is the concept of matter. Everything in the universe, it is made up of material that scientists they call as matter. You, me, the air that we breathe, the food that we eat, stones, clouds, stars, plants, animals, even the small drop of water or a particle of sand, everything, remember, is made up of matter. How exactly do you define matter? Remember, matter is anything that occupies space and that has mass. Right? Remember, I'm using the word mass and not weight. Weight varies from place to place, but mass remains the same. Alright, that is the matter content that remains the same. So mass, anything that has mass and anything that occupies space is called as matter. For example, you are occupying space, you have mass, so you're called as matter. In other words, they have both mass and they have volume. Right? Let's now talk about characteristics of matter. Alright, matter is made up of particles. Alright, what these particles are today, we ended up calling them as atoms, right? So Kannada Rishi, if you remember, he is the Indian philosopher behind this ancient Indian school called as Vaisheshika. You might have heard about this. This is a school of logical reasoning, rationality, etc. Right? This is, I hope you know about the orthodox schools. We have yoga, we have, like Samkhya, etc. Along the same lines, we have something called as Vaisheshika, and Kannada Rishi is the chief proponent in this particular school. So Kannada Rishi, he ended up saying that if you break matter, if you break objects around you, you can keep on breaking them, keep on breaking them. Ultimately, you will arrive at a small particle. This particle cannot be further broken down. So all matter around you, everything around you is made up of these particles, and this person, Kannada Rishi, he ended up calling this as Parma. Alright? Modern time, we call it as atoms. Right? So the first contribution towards particle physics or atomic theory has been propounded by Kannada Rishi. Alright, obviously nowadays we associate atomic theory more with John Dalton, of course, we'll be talking about that very soon. So matter is made up of particles. These are called as atoms. Particles, remember, they have spaces in between them. How do we know this? Remember, if you add salt to water, what happens? The salt dissolves in water. How exactly is this possible? The salt is able to dissolve within the intermolecular spaces that are present inside the water. So that is the reason we can conclude that these particles, they are not so tightly packed. They have some spaces between them. So that's how the particles of salt are able to dissolve in water. Why? Because particles of salt, they are occupying the unoccupied spaces, the empty spaces in the water particles, between the water particles. Alright? Particles of matter, remember, they are continuously moving. There's a terminology for this, I will be using this. The particles, if I say this is matter, this is a box, it's made up of particles like this. Alright? I'm telling you, these particles are continuously in motion. Right? Any object that is in motion is said to have something called as kinetic energy. Alright, because I am not in motion right now, I don't have kinetic energy. But if I throw this pen around, this pen will be in motion. So this pen will possess something called as kinetic energy. Alright, as temperature rises, the particles, they move faster. What is the reason behind this? Remember, if you are providing temperature, if you are increasing temperature, you are providing more energy to the particles. If you are providing more energy, you are increasing the kinetic energy to the particles. So that means they will start to move faster, right? That's what this kind of motion of particles, this kind of motion that is exhibited by the particles is often referred to as the Brownian motion. Alright? And if you talk about kinetic energy, any object in motion possesses kinetic energy. Okay? This kinetic energy is given by the formula half mv square. Alright, m stands for mass, v stands for velocity. Velocity is nothing but a vector quantity. In other simple words, you can call it as speed. Of course, there's a difference between speed and velocity. However, for now we can use them interchangeably. So if you see an object that is not in motion, for example, I'm not in motion, I'm sitting over here, so that means my speed is zero. That is the reason what happens is kinetic energy becomes zero, right? So that is the reason having mass is important, having velocity is important. If either of them is zero, if you don't have mass, you cannot possess kinetic energy. If you don't have velocity, that means if you're not moving, automatically your kinetic energy is equal to zero. Alright, what am I trying to tell you right now? I'm trying to tell you that you are increasing the temperature. Temperature means heat is just another form of energy. When you are providing more heat, you are increasing energy. This energy gets exhibited in the form of faster movement among the particles. Alright, so anyway, if you heat, the particles, they tend to move faster and they will also tend to move further away from each other. Right? So anyway, any particle, remember, it is made up of matter. These matter, they are continuously in motion, and this motion is called as Brownian motion. Alright? Particles of matter, remember, they have forces acting between. Right? How do you think I'm not able to break this pen? Because there are certain forces that are acting between the particles that are holding them together. Right? The forces, it keeps the particles together. We will be stressing more on these forces. Right? I will be giving you a lot of terminologies in the future. The strength of this force of attraction, it varies from one kind of matter to the other. For example, if I take maybe a pencil, if I try to do like this, I would be able to break a pencil. But if I do the same thing with this pen, I'm sure it is not possible. Why? Because the strength of this force of attraction is greater in this pen than in this particular pencil. Alright? So that's what. So there are some attractive forces that are keeping the particles of matter tightly held together. Alright? This brings us to a discussion on different states of matter, right? As a kid, you might have been taught about three different states of matter: solids, liquids, and gases. I am going to introduce you to two more concepts. One is going to be called as plasma, and the fifth state of matter is going to be called as Bose-Einstein condensates. And very surprisingly, you will see in 2018 General Studies Mains Examination Paper 3, GS Paper 3, which also asks questions related to science and technology, a 10-mark question related to Bose-Einstein condensates, Bose-Einstein statistics was asked in the paper. Alright, I will be telling you about the question, how you could have answered. I've also written a mock answer in my blog. You can check it out. I'll ensure that the link for that answer is available in the description box below. Alright, let's talk about the states of matter. Solids. Solids have a definite shape. For example, this pen is solid. It has a definite shape. It has distinct boundaries, right? It is not flowing. It is always going to be like this. It has a fixed volume. If I put it in any container, it is going to stay the same. Its volume does not change. And there is negligible compressibility. I'm trying to compress it like this. I'm trying to put pressure and trying to compress it. But nothing really happens to solids. Why? Because they have negligible compressibility. I cannot compress it. Solids, remember, they have the tendency to maintain their shape when subjected to outside force. See, so much force I'm applying, despite that the solid object is able to maintain its shape. Right? So that's what has the tendency to maintain shape even when it is subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. Remember, if I put a lot of pressure, the solid object at one point of time, it will snap open, it will break under force, but nevertheless, it will not change its shape. That's why I call it as rigid. Right? Solids are described as rigid. These are all characteristics of a solid. They have definite shape, they have distinct boundaries, they have fixed volumes, they have negligible compressibility. That means it is very difficult for us to compress them. Very, very difficult. Maybe negligible amounts we'll be able to compress them, but not beyond that. Right? As I told you, even under pressure, outside force also, solids have the tendency to maintain their shape. Alright, and however, solids may break under force, but it is difficult to change their shape. So we call solids as rigid. Let's now talk about liquids. Liquids, remember, they have no fixed shape, right? But they have a fixed volume. It doesn't matter if I'm putting water in this particular glass or if I'm putting it inside this particular flask. Okay, if I have 100 ml of water, the 100 ml of water will remain the same. So it has fixed volume, but it has no definite shape. If I put it in this glass, it will take the shape of this glass. If I put it in the flask, it will take the shape of the flask. Alright, that's what. It has no fixed shape, but has a definitely fixed volume. It will take up the shape of a container in which it is kept, right? This is very simple to observe. Go to your govt, fill your water in different kind of glasses. You will see water, liquid. It takes the shape of the container, all right? And remember, one property of liquid is that liquids, they flow. They flow. Solids don't flow. I can hold a solid like this, it won't flow. But if I put water over here, you can see the water is starting to flow, right? Liquids flow and they change shape. This is the reason they are not rigid. And therefore they are called as fluid because they are able to flow, alright, and they are not rigid. So they have no fixed shape because they take the shape of the container, but however, remember, they do have a fixed volume. Okay, let's now talk about gases. In gases, particles, they move about randomly in a confined space. So that means if this is my room, inside my room, gas particles, they are not so tightly held. So that is the reason they are roaming from one place to the other. They are randomly moving from one place to the other. They have very, very high compressibility. You can compress all the gas in this room and you can store them in a tiny, cylinder or something like that, right? You might have seen CNG cylinders, LPG cylinders, etc. Remember, this is how we are compressing them and we are storing them under great pressure, right? If you leave them, these gas particles will spread throughout this particular room. Alright, these are the three states of matter. All of you are already very familiar with these states of matter, right? So you can see this is an example of solid. You can see this is a plate. If you look at the particles, there are hardly spaces between these particles. Alright, they are tightly held, they are very rigid. If you look at liquids, you can see that there is quite an amount of spaces between the particles. But over here, you can see there is large enough space between the particles. That is the reason they are able to move about easily. Alright, so that's what makes this very, very rigid, this fluid, and this completely free. Alright, now let's take this discussion one step ahead. We are going to talk about two important concepts. One is going to be plasma, as I promised you, and second concept is going to be the Bose-Einstein condensates. Alright, let's talk about plasma. The state consists of super energetic and super excited particles. What is this? What exactly do we mean by plasma? It has super energetic. That means you have these particles. These particles have humongous amounts of energy. They are super excited, right? They are bustling about. They have so much amount of energy. Remember, these particles are in the form of ionized gases. Let's just try to understand what exactly is an ion. Ion, for now, I will be telling you how ions are formed. But for now, just remember ions as charged species. Right? You can have negative ions, you can have positive ions. Basically, ions have a negative or a positive charge. Okay, that's what we mean by ions. So basically, the plasma is nothing but ionized gases. These are gases that are made of particles that are called as ions, right? That means they have some sort of electric charge on them. Okay, if you look at fluorescent tube, neon sign bulbs, etc., you might have seen this in many movies and all, right? In Hollywood movies, if you see, there is this motel that is written, right? You might have seen it will have this flickering light and all. That neon sign bulbs, remember, even that contains plasma, right? Fluorescent tube, you can Google them, you will be able to see neon sign bulbs, right? All this consists of plasma. Inside a neon sign bulb, there is neon gas. Okay, if you see neon sign bulb, obviously neon gas is there. Inside a fluorescent tube, remember, there is helium gas or some other gas also could be there, right? You can see I'm using helium, I'm using neon. If you see, these are all called as noble gases. They don't react so easily, right? The gases, remember, when do they get ionized? They get charged when electric energy flows through it. So let's just say there is this tube, alright? Inside this tube, let's try to say there is some kind of gas. It could be neon or it could be helium. Right? Such a gas is kept over here. What is happening is, through this particular tube, I'm passing electricity. Right? Electric energy is being made to flow through this tube. Right? Automatically, what happens? This charging up. Right? That's what. See, the gas, it sets to get ionized. That means when I'm passing this electric energy through the tube, the gas gets ionized. That means ions are being formed. Right? Charged species are being created. Okay? This charging up creates a plasma that glows inside the tube or the bulb. Right? This incident, this charging up of these ions, because of the application of electric energy, what happens? This creates a plasma that glows inside the tube. You will be able to see that it is emitting light, it is glowing, right? The plasma, remember, it glows with a special color. The color with which it glows, it depends on the nature of the gas. What kind of gas are you using? Are you using helium? Are you using neon? Or what else? That determines the special color in which the plasma is glowing. Okay? Where do you naturally see plasma? If you look at sun glow, if you look at stars glow, remember, the glow of the suns and star. Remember, sun is nothing but a star. Okay, so there's no need for me to write it specifically. Also, sun is nothing but a star. All right, the star that is closest to us is the sun. The next star that is closest to us is called as Proxima Centauri. We'll discuss this when we discuss about solar system. Okay, the sun, the stars, they glow because of the presence of plasma. Okay, how is plasma created in stars? They are created because of very high temperature. Right? If you go to the core of the sun, the temperature is very high. Because of this, plasma is generated over there. Okay? That is because of high thermal energy can also be responsible for creation of plasma. Right? This is the fourth state of matter that is called as plasma. Next state of matter is even more interesting. It is called as Bose-Einstein condensates, and as I told you, a question, right? Let me write it for you. Question related to Bose-Einstein statistics, right? Not condensates. Statistics was asked in General Studies, paper 3. This is 2018 mains examination. Okay. Fortunately, whenever I teach science and technology to my students, I end up teaching them right from class 6 NCERT. I also end up teaching them particle physics. So they were already aware of what to write an answer for Bose-Einstein statistics. Alright. So even if you don't know what is Bose-Einstein statistics, some mention of these things would have still fetched you marks. It was a 10 marks question. Alright. I've written a mock answer for this. This mock answer is available on my blog. I'll ensure that the link for the blog, the answer is shared in the description box below. Alright. States of matter. The fifth state of matter is called as Bose-Einstein condensate. Alright. In 1920, you will see Indian physicist S.N. Bose, that is Satyendranath Bose. had done some calculations for the fifth state of matter. He was able to theoretically predict the existence of the fifth state of matter, right? On the basis of the calculations, mathematical work done by S. N. Bose, Satyendra Bose, Albert Einstein was able to predict a new state of matter, right? This new state of matter, the fifth state of matter, is often called as Bose-Einstein condensates, alright? BEC. If you remember nowadays, we talk about a class of particles, they are called as bosons, right? For example, you might have heard about photons, right? Photons are particles that make up light, right? Light has dual nature. It is a wave, it is a particle. When light is behaving like a particle, we will be talking about light very soon when we take up class 10 NCERT. I'll be going beyond the NCERT, I'll be telling about photoelectric effects, etc. But for now, remember light, when it is behaving like a particle, it is said to be made of these particles called as photons. Okay, photons belong to a class of compounds. They are called as bosons. Right? There are other bosons also: W boson, Z boson, Higgs bosons, etc. This word bosons, where do you think this word is derived from? This word is derived from the name of S. N. Bose. Right? It is derived from the name of Satyendra Bose. This talks about the kind of contribution made by S. N. Bose. Alright? So, you see, even though Albert Einstein and S. N. Bose, they predicted the existence of the fifth state of matter somewhere in the initial 1920s itself, only somewhere in 1995, on the late 1990s, the existence of the fifth state was proven. And the people who proved them, Eric A. Corner, Wolfgang Kettle, and then we had Curly Wyman. So these people of the United States of America, they received the Nobel Prize in Physics for achieving the Bose-Einstein condensate. So they were able to create this in a particular laboratory. Okay, so that's the reason they were awarded a Nobel Prize. Okay, so you might ask this question, why not? Why was Satyendra Bose, Albert Einstein not awarded? They predicted it long time ago. Remember, Nobel Prizes are never given posthumously. Okay, after you die, Nobel Prizes are given. Only exception to this rule is that if I announce you as a Nobel Prize winner, then after that you die, then the award will be given to you. But otherwise, to a dead person is not announced the winner of the Nobel Prize. Alright, so only exception is that. So these three people, they were awarded the Nobel Prize for achieving this Bose-Einstein condensation, that is the fifth state of matter. Let's try to understand what is this fifth state of matter. How does it actually look like? Okay. The Bose-Einstein condensate, it is formed by cooling a gas of extremely low density. Remember, when talking about class 7 NCERT, I have already given to you the concept on density, right? I already told you what is density. It is mass per unit volume. Remember, I told you, if an object is packed like this, and if an object is packed like this, right, I told you this has high density, this has low density. Alright, this has low density. Right, high density means it is more tightly packed. The particles are tightly packed. Remember, we just talking about particles exhibiting Brownian motion, etc. This is loosely packed comparatively. Okay, there could be some other matter also that is even loosely packed than this. Okay, its density will be even lower. So what are they saying? They are saying, how do you achieve Bose-Einstein condensates? How do you achieve this fifth state of matter? You basically take a gas. Okay, this should be extremely low in density. How much low should the density be? This should be 100,000 density of normal air. That means you take density of normal air. Right? You divide this density by 1 lakh. Right? You're getting the point? So that means if you have 1 in 100 particles of air, so this should be even lower than that, right? You are talking about a density that is extremely low. How low? 100,000th less density than that of normal air, right? What are you doing? You're taking such a gas, it is of extremely low density. Remember, the word is extremely low density. And what are you doing? You are cooling it down to extremely low temperatures, right? So when this happens, you get a fifth state of matter that is called as Bose-Einstein condensates. You might ask me this question, what is so special about it? Why is it a different state of matter? Why? The main reason is that this fifth state of matter, at this point of time, this gas, it exhibits certain phenomena, right? It exhibits certain phenomena that is not observed in the other states of matter. For example, at this extremely low temperature, we talk about something called as superconductivity that is also observed, right? Superconductivity means there is no resistance to the flow of electricity. Electricity is flowing through you. There is no resistance. Remember, we don't like resistance. If there is resistance, so that means the efficiency of conduction of electricity is hampered, right? So that's the reason we use gold, silver, etc. These are called as good conductors. Why? Because they offer less resistance. In superconductivity, remember, no resistance is offered to the flow of electricity. Electricity can easily flow. So there is no wastage of electricity. There is no heating, etc. taking place. This is the most efficient way of transferring of electricity. Right? Superconductivity, these are topics we will discuss in future classes. Alright? So that's what. The Bose-Einstein condensate is formed by cooling a gas of extremely low density. The density should be so low that it should be lower than 100,000 density of the normal air. You are going to cool it down to extremely low temperatures. Okay? What do you get? You get the state of matter called as Bose-Einstein condensate. Alright? This is the fifth state of matter. I hope you are clear with all 5 states of matter, and as you can see, you should not be flabbergasted by this question on Bose-Einstein statistics. I know this is a different concept. Remember, this Einstein statistics, this is basically like rules and regulations for bosons. Okay, this class of particles I will describe. For example, photon is a boson. What are the rules and regulations that should follow? Right? Should they follow Pauli's exclusion principle or not, etc. That is what is given in this Bose-Einstein statistics. Okay, it's basically rules and regulations for something called as bosons. Alright, I will be conducting a class on particle physics, rules and regulations for bosons. Okay, how will they behave, etc. That is given by Bose-Einstein statistics. Alright, an example of boson I told you is photon. Right, there are something called as W bosons. There are something called as Z bosons. Right, these are examples of bosons. Okay, nevertheless. Okay. So as you know, remember, we talked about 3 different states of matter that we usually get to see. 4th and 5th stated under exceptional circumstances we are seeing. For example, the 5th state of matter, Bose-Einstein condensates, that is something you get to see only at extremely low temperatures. Right? So those are all exceptionals. Usually we get to see solid, liquid, and gas around us. And remember, all these states of matter, they are interconvertible. Okay? Let's take example of water. Remember, solid form of water is called as ice. The liquid form of water is called as water. Okay? And finally, the gaseous form we call it as water vapor. Right? So as you can see, the same H2O, 2 atoms of hydrogen combined with 1 atom of oxygen. So they are existing as ice, that is a solid form, as water, that is a liquid form, as water vapor, that is gas form. See what happens when you heat ice, it starts to melt, it becomes water. When you further heat water, we boil it, etc. So it gets transformed into water vapor. Similarly, when during the process of condensation, remember, if you remember our discussion on hydrological cycle, the water cycle, when we talked about 6th standard NCERT, there I told you about how water vapor, as it rises up, the temperature is reduced, it starts to cool down, it undergoes a process called as condensation. So that means when you reduce the temperature, water vapor is turning back into ice. Right? When you are further reducing the temperature, water gets converted into ice. Right? If you put water inside the freezer, what happens? It gets converted into ice. Why? Because the temperature over there is less than 0 degrees centigrade, and at and below 0 degrees centigrade, water exists in the form of ice. So what I am trying to explain to you is that all these states of matter, they are interconvertible. Converting them from one state of matter to the other is totally possible. Right? For example, when solid gets converted into liquid, this is by extreme heating, by heating and all. This process is called as fusion. Right? This process is called as fusion. On the other hand, liquids can convert back into solid. This process is called as solidification. Alright. Similarly, liquid can get converted into gas. For example, water getting converted into water vapor. This process is called as vaporization. And remember, water vapor can also get converted into liquid, into water. This process is called as condensation. Remember, this process is very crucial for precipitation, for rainfall. Okay? Alright, sometimes what happens is, I am sure you might have seen camphor. It is something that we use in our puja, etc. Camphor, it undergoes a process called as sublimation. It is directly able to get converted into gas. So without, for example, if you heat ice, first it gets converted to water, then if you heat it further, it goes to water vapor. But something special about camphor is that it is able to undergo sublimation. Sublimation means solid is able to directly get converted into gas. Similarly, the other way around is also possible. The gas can also through sublimation can be directly converted into solid. Alright, so here I am trying to establish the interconvertibility of the different states of matter. Alright, so we will stop over here for today's class. Alright, so I will be taking up the leftover topics. Tomorrow I will be taking up the concept of evaporation, various factors that affect evaporation. Then we will be explaining some of the most observed common phenomena around us. Then following that we will take up a discussion on solutions, on colloids and suspensions, etc. Then we will be talking about separation of matter, purification of matter, and all. In the future classes, we will be talking about elements, compounds, and atoms and ions. All those concepts will be made clear. We will be talking about isobars, isotopes, etc. So you can stay tuned for awesome lessons by me, Siva Prasad. As I told you, I teach live on Unacademy Plus. This is my name, Siva Prasad. You can search for me on Unacademy, and if you plan to subscribe to Unacademy Plus, try to use my referral code, that is AKMSIVA. Right? This will give you a flat 10% off on your subscription. There are a lot of awesome courses that are being conducted on Academy Plus, which will help you in a comprehensive coverage in preparation for various examinations like UPSC Civil Services examination, various state level examinations, SSC, etc. Do check out Unacademy platform. Thank you so much and have a good day.